Okay, so thank you for the opportunity. Just something about me. I'm Luís. I'm a software developer or product developer, as I like to say. In NewStore, I was in team inventory. Now I'm in team checkout. And yeah, being a product developer, I like to be user-centric and do whatever it takes to put value in the user's hand as soon as possible and as frequently as possible. So I try not to be into a specific layer like front end or back end, or even just being a programmer. I try to get involved outside of that. So to make sure we're doing the right thing rather than going back and forth. Yeah, so enough of my philosophy. Let me share. Okay, tell me what you see. Yeah. Can you see a building, like a futuristic city?
Yes, this looks good. Like your slide, front slide. Great.
Okay, so let's start this. This is about domain-centric architectures, and this is not a very common sentence or phrase. It's just an umbrella term for what you commonly hear as clean architecture, hexagonal architecture, which, by the way, is a synonym of ports and adapters architecture. Also, onion architecture, screaming architecture. All of these could fit into the umbrella term called domain-centric architectures. The domain part comes from the DDD, so they are inspired by DDD. The domain part means that you put the domain in the spotlight. It has a high degree of importance, as we'll see. So there's two ideas that I will try to get across. Although I have like around 25 slides, there's only two ideas that I will try to get across. And the first one is about separating domain code from infrastructure code. So there's a myth that people buy into sometimes, which is like, if you have clean architecture, you have to have all of it. Then you bring this heavy thing that you read in an article, you need all those concepts that you saw in that Medium article, and then you have clean architecture. I don't believe it should be that way. Just as in DDD and also similar concepts, you bring what it makes sense when it makes sense. You start simple and you evolve if you have to, if you need to. So don't do the same as in code. Don't do generic code when you don't need to. Here it's kind of similar. And the main idea that we should bring soon is this, about separating domain code from infrastructure code. By the way, the examples are in Python and Kotlin because I just started working in Go, so I didn't feel enough confidence to do them in Go. Maybe next time, but I'll leave it as an exercise for you. Okay, let's deep dive into this division that I just mentioned, infrastructure versus domain. What is the domain? The domain is if you have like a commercial application, the domain is short for business domain, but it doesn't need to be. If you're building some personal CLI tool, the domain is just the area where you're working on, the concepts that you're trying to solve, the problem that you're trying to solve. This is the domain code. It doesn't need to be a business, but it's about the problems that you're trying to solve. In hexagonal, it's known as core. In other words, it's the reason why your app exists. It's the essence. And it has no reference, or it should have no reference to technology. That's the idea that I will try to sell you. So it's like the brains of your app. It can be compared to a human brain in the way that the infrastructure is like the senses around it. So the infrastructure is everything that it's not the area of expertise, the area where you're trying to solve your problem. It's about technology. It's about input output. It's about delivery mechanisms like UIs and storage mechanisms like databases, communication mechanisms like event communication. And yeah, another difference is that the domain is high-level code. So you could read it almost as you were reading a book, while the infrastructure, you are reading technical code, let's say, like store that, give me that. It's more technical, let's say. The domain is everything that you can think of everything like even without computers, you would still have to solve these problems. And an important concept is that it should rely on the ubiquitous language that Lucas mentioned. It's the language that your users are using daily. So you should try to refactor as you go, as you bump into problems, as you learn more about them. You refactor constantly to make sure that the domain is mapping those concepts into code. Going a little yeah, okay. Before that, so sometimes I hear the myth that, oh, I don't need that. I don't have enough complexity to justify clean architecture. And while that may be true if you think about the full-blown clean architecture or hexagonal, it's not all or nothing. You can still have at least two concepts: the separation from business code from infrastructure code, and the usage of the ubiquitous language that you can have from day one or day two. You don't need to, oh, now I'm going to bring this architecture. So a good architecture is an evolvable architecture, and good architecture is not more complex than a bad one. That's another myth, a related myth. So even you have a console app, a very basic console app, from very early on, you want to have the parsing separated from your algorithm and separated from the printing. Otherwise, your head just blows when you try to fix some issue, because you're handling parsing issues with the actual problem that you're trying to solve. It's all mixed like spaghetti code. So doesn't mean that you need like complex interfaces. All you need is three functions: one to read, one to compute, and one to output. This is in the console app. And if this applies to a console app, I wonder why it doesn't apply to your more complex services that you're developing. This is important. So another way to look at this, it is a slide we saw before, but trying to understand the flow of the way your app is called and how it is triggered. So on the left, you have a primary actors. So it can be a user, a job, something else that triggers your app. The infrastructure starts by parsing in some web handler or something. It passes the flow to the internals of your app. So the core, where a certain use case is executed. It goes to a database, etc. It goes all the way back to the user. And in between, the languages are converted from the outside in and the inside to the outside. So there's a couple of transformations here, a few transformations, business code in between. This is the flow of control. Another thing to have in mind, which is not to be mixed up, is the dependency rule, which I think it's one of the solid principles. And it states that the outside depends on the inside and never the other way around. So again, the domain is to be protected. It's not to depend on any technology. It shouldn't have like words like JSON, HTTP, any of those words that feel technology should never appear in the domain. And because again, the goal of this architecture is to protect the domain, make it more stable, because that's where the business happens, and it should be easy to read, maintain. Going a little deeper in the infrastructure, it's usually split into the driving side and the driven side. I kind of hinted about that before when I spoke about the flow of execution. So the driving side represents the part that calls your app. Like if your app was sleeping, it would be woken up by the driving side. And the driven sides are the things that happen because of your app, like databases and third-party calls. A myth that I also hear about is that clean architecture, it's about replaceability, because, oh, I'm never gonna change my database. That's fair and that's likely, but still, the main thing about clean architecture or similar, it's not replaceability. That's just a side effect. There's less buy-in into specific technologies. That's great. it insulates code changes. So if you want to refactor a certain, because some other third party changes a certain field, you do it into one place, the proper adapter. But still, I think for me, the main reason it's not replaceability or insulating, it's about maintainability, because you can see that these concerns are separate. When my mind is in business mode, I'm not in technological mode, and vice versa. So I think, to me, that's the biggest achievement. It's also, you could also argue that it's about testing, because you can easily replace the adapters. But again, it depends on your testing strategy, because personally, I like to test full stack by default, but that's another presentation, another talk. Again, the goal is to separate the what from the how, the accidental complexity from the inherent complexity of your app. Going slightly deeper into the adapters part, so you can see the green circle. It has this little greener circles inside. These are the adapters that I've been mentioning. They can encode stuff like CLIs, handlers, jobs, migrations, UI handlers if you have a full stack app. Basically anything that can start your app, trigger your app logic. The adapters are supposed to be thin, so there should be no business logic at all. If you have ifs, it's already a hint that you're doing it wrong, probably. So it's all, again, think about the console app that I mentioned before. It's all about parsing and converting between different languages. If you're talking to a third-party API, you're converting to their language and then converting to your language when the answer comes back. So it's about transformation, never about ifs and else's. This is logic. It happens inside. The outside, the thing that it's not the green circles, it's also infrastructure, but it's not in your control. So it doesn't matter much. It's like the HTTP client that lives in your native standard library. It's also infrastructure, but you don't have to code it because someone else did it for you. So that's why I'm focusing on the adapters themselves, the things that you code. And this is the dirty architecture, like the opposite of the clean architecture. So when you have business logic in the outer circles and technology in the inner circles. A simple thing like reading an mvar shouldn't happen inside. That should be injected, and nobody inside the domain should know about the mvars, because again, that's technology. I could give 1,000 of examples, but I want to focus on the second part of the presentation. So this is another concept where actually the first slide, the thumbnail, the first slide had a similar image. This is like a futuristic city, and I like the metaphor because this guy designed cities like concentric circles, which reminds me of this that I've been talking about, which have these connectors to the outside other cities. And the metaphor doesn't hold for long, but I like to think it this way. When you have your own apps and they talk through adapters. So you can think of this like cities, and then the inside of the cities are more stable and have to be protected. And the outer sides are the things that contact other apps. In DDD, you can probably model this as bounded contexts, maybe. That's another conversation. But anyway, everything that has a domain logic should live on the inside of each one of these little islands, let's say. So these concepts that I'm talking about apply to each deployable, let's say. Okay, well, I think we covered enough of infrastructure. Going to the domain now. And the domain, it's, again, the inner circle. It's comprised of many things, but I want to focus on the use cases and the entities. Starting with the entities, these are, probably you heard about them. Just to summarize, these are abstraction of business concepts like article, user, loan, car. These are concepts that you manage, and and they are not TTOs, they are not serializer. They don't know, again, nothing about technology like Jason. These are concepts that live in your domain and represent the business things that you manage. They are also not database tables because of the same reason. They have logic. So another myth is that your entity should be anemic. That's actually an anti-pattern. So you should not do stuff like set status on an entity because that's managing data. An entity, you're supposed to do business operations on it using the ubiquitous language, like, I don't know, upgrade user. And of course, that's going to change its status. I don't care. But you talk to an entity giving it orders, let's say. And going to the use cases now, they abide by the same rules there, but they are more like they encode actions that your domain is supposed to be able to do, like submit article, get loan, list users, make deposit. This is stuff that happens to your entities. Some of them will change their state as a whole. There are stuff like ports, value objects also inside here, but for today, let's talk about use cases and entities. So this is an entity. Again, it has state, but the most important things it's actions. And the use case, this is an example of use case. It's like it has an input, it has an algorithm with steps, and it has an output, or in this case, this is a query, so it has an output, but it could have supposed to have a change of state of the system. It depends on the use case. Use cases are relevant for the rest of the presentation, so let's talk a bit more about them. So what is a use case in practice? It's just a public function. It can be inside a class if you're object-oriented. It can be just a public function. It starts with a verb because it's supposed to do an action, and that verb can be a query or a command. So if it's a query, it's supposed to return you something. If it's a command, it's supposed to act on the system, changing its state, mutating it. So again, I don't know, list movements, it would be a query, withdraw money, delete my data, pay shopping cart, it's a command, it changes the system state. In practice, so a use case, it's encoded in a file, and it can have, it should have all it needs to be fulfilled. So there should be no sharing, but we'll get back to that later. Use case should be pure, so it should be deterministic without side effects. Maybe there are some exceptions, like, I don't know, you might want to log, even though it's a bit ugly in the domain, but sometimes you may need to log, although I prefer to log in the outside of it, of the app, in the infrastructure. But okay, it's important to know the rules so you know when to break them. A use case, it's also known as an interactor, I think, in clean architecture, because it's supposed to interact with the surrounding adapters, like databases and stuff. In this case, repositories, if you're using the clean architecture terms. There's an important myth to tackle here, which is that the use case can be CRUD, like CRUD, but that's wrong. CRUD is a technical concept. Create, read, update, delete, everything like this. This is technical, and use cases are about domains. So it's not like create loan, update loan, but then the update loan will have 2,000 lines file, will be a 2,000 lines file, because it's not doing one thing, it's doing many things in the perspective of the user, and use cases should encode actions on the user point of view. So intents, let's say, it has a purpose. You have to think as a user when you're encoding these things in these functions, in these use cases. Yeah, it should, I think I told this before, it should start with a verb. Just like any other function, but here it's even more important because it tells right away what's its purpose, its intent. Yeah. This is an example of a use case. So you have a class, you have one function, which is invoke. This is just the Kotlin way to make this class invocable without having to say dot invoke. It's a convention. It has a DTO, which is encoded down here, is a data class. So you don't have to go elsewhere to understand what is the language of this use case. And in this case, it's a command, so it changes the system state. It doesn't have a return, it just saves the user. However, if you're listening to me before, this is a bad example of a use case, and I left it here on purpose just to make a stink on this, because create user feels technical, right? You have to think as a user, and the user doesn't create the user. You probably want to register. Typical example is that you don't create a bet, you place a bet. So one is technical and the other is the intent of the user. But I left it here just to talk about it and see an example of a use case. Use cases forces to think about in software in terms of behavior, not in terms of data. So software shouldn't revolve around databases, around data schemas. Software should revolve around the domain and around the behaviors that your app offers to the world. Yeah, so going back to this that we saw before, the driving side and the driven side, in practice, what does it mean? This use case has to be offered somehow to the world. So remember the concentric circles, the infrastructure part, the left side is the driving side, and the right side is the driven side. On the left, you have the way that this use case is offered to the world, is delivered to the world. In the middle, you have the use case, which we saw before. This would be in the center. This would be in the core. And now you can see the left and the right, the driving side and the driven side. So none of these sides, let's say, is leaking into the insides of your app. There's no references to handlers inside the core. There's no references to databases inside the core. These are just the left side. This is just a web handler, just a delivery mechanism. Ultimately, you could reuse the use cases that we saw, this use case that we saw before. You could use it on some other place, like a job. We do a lot of scripts, for example, and the scripts use these use cases. The same exact use cases. Thereby, you don't bypass any business rule, like going directly to the database. You have to comply with the core of your app, regardless of the entry point. So I kind of hinted already, and this is the second idea I'm trying to sell you, is that the use cases should be more important than they usually are. They are like the building blocks. They are first-class citizens of your app. That's the second idea I want to try to sell you. Before getting there, let me mention what is a code hotspot. So it's like a code hotspot. It's like a black hole of code. So every time you have a new feature, you have to change that place in your code, and then it grows to infinite, right? The limit grows to infinite. There's no limit. Whenever you add features, you are changing that file, and it grows to infinite. You can have technical hotspots like a big web handler with all your routes, or like an exceptions file, which is super ugly, utils files. These are technical hotspots. Or you can have business hotspots, like a huge service file, like user service, something like that. Both are hotspots. What's the problem with hotspots? So one myth is that we should be careful with layers in software, like a UI layer, and then the business layer, and then the database layer. This is good, but this is overrated. People talk too much about this, and nobody is talking about separating your code vertically, like each use case being more independent and having its own autonomy and identity, and not promiscuously sharing code, and like DDOs and utility functions. And due to that, these code hotspots, they end up with a huge blast radius, and you're scared to change code because you don't know who else you're going to impact if you're changing a function that is used 30 times, even if you have good tests, there's also a degree of always a degree of psychological unsafety. There's also developer experience because you keep fixing merge conflicts because everyone is contributing to the same files, and all you can resort to is Command F or Control F. There's no other tools for you to find stuff in those huge files, that grow to infinite. And finally, the dependency injection is ultra ugly because you have 25 injections in your assembly part of your app, and you don't know who depends on what. It's hard to tell because everything is injected into the user service, so it's hard to tell which action depends on what. This is especially worse in tests if your testing strategy needs to isolate your domain, then your domain actions have to inject 25 dependencies, and it's hard to tell. And you're only needing 2 of them maybe, but you have to inject 25. So messy dependency injection to sum it up. Technical hotspots, just a quick summary. Technical hotspot, these are typically folders like validators or files like validators, exceptions, requests, responses, etc. This is not the way to organize your software. This is around technicalities. They are not the main actor in your app. They are secondary. The main things in your apps are use cases. Again, I'll keep repeating that to make sure my message passes, is use cases all the way. Use cases first-class citizens, and apps revolves around them in implementation code and in testing code. So this is just another way to see it. You have multiple blocks. This is the vertical decoupling that I was talking about. You have order food use case that it's the green part is the domain part, it's the actual use case. The blue part is just that slice of it that is the way you deliver to the world, which potentially might change, but it's isolated from the green part, the domain part, the inner circle of our previous the initial slides. And this kind of splitting, this vertical splitting, putting use cases in files, is the solution for code's hotspots. Because whenever you want to grow, you grow just with a new file. There's no files that grows to infinite. You have folder that may grow a lot. It's okay. Then you might have subfolders if you need, but each file that will never grow to infinite, because one use case is supposed to do one thing and do it well, not many things. Just one public function doing one thing, a query or a command. That's enough for a use case. It has all it takes to achieve it, like requests and responses, DTOs, etc., and exceptions maybe, or errors. So yeah, again, splitting by use case is the solution to this. A nice outcome of this is the screaming architecture. So if you make your app revolve around use cases, you end up with the right side where you are new to the project, you just arrived in this team, you browse the code and you don't see technicalities. I think, for example, in Rails apps, it's a bit like on the left, you just see technicalities. You don't see what is this app for, because if you see technicalities, all the apps look the same. When you look at them, every app looks the same app in the world, and the right side is the way that makes your app be your app. It revolves around its intents. And the same goes for testing, but I don't have enough time to talk about testing. I just want to say that testing should also revolve around use cases. So each file represents an intent, a use case. So just different scenarios of the same use case. This is just another way to put it. You might have your entities under entities and your use cases in a special folder, and then you can clearly see what is this app for. You don't know anything about this, but you can already know that this is probably some like Uber Eats app, just by looking at the list of stuff that the app is able to do. Another folder is missing here, which is the way you deliver it to the world. Okay, you can also put it here. But this is about the domain, and the domain doesn't need much more than this. Now, these screenshots, I took it from a real app in the previous team I was at. And you can clearly see in the middle, this is the center of the circle. Remember the initial slides? The use cases that are in the center, they belong to the domain. And again, looking at this, you already are hinted about what this app can do for you. This is all the actions that the app is able to do, whether queries or commands. On the left side, you have entry points. This is the way that you deliver those use cases to the world, which can be scripts or in this case, it's a web app. So you'll have, a web API, you'll have routers delivering this same, it's probably one-to-one because you want to expose these use cases to the world with these routers. But it doesn't need to be one-to-one, by the way. And again, the scripts, it's about reusing the domain knowledge that we've encoded in the domain circle. Regarding the tests, I hinted about this, that they should revolve around use cases. And I won't go into details. This is just, this deserves another presentation, another talk. Very quickly, I just want to say that it's nice that you have this HTTP DSL that just encodes your use cases. This is actually one of the things kind of like this we're doing I just arrived to a new team where we have everything in those huge files, those code hotspots, gigantic files. And the best way to tackle this complexity, to untangle this spaghetti code is to start with the tests. Otherwise, you don't feel safety net. You don't feel safety while refactoring code. So, okay, let's start with the test. What we started with was this DSL, the domain use cases. They are encoded in these testing clients. Let's say they are like proxies, and now you're going to use this language in your tests. Okay, this is where you start, and later you're going to reorganize your app by use cases. But that's only the last step. This is where you start in the tests. So this is also a nice slide to understand that you can visualize the testing strategy using this visualization. You can pick and choose whatever is best for you and your team. Personally, I prefer this full stack tests that go all the way. But again, you can pick whatever you desire depending on your strategy. So to finalize, let's talk about advantages. So using this use case oriented approach, you have faster refactorings in your IDEs because IDE probably doesn't have to compile everything, just focusing on one file, and you feel safer doing that. There's barely no scroll. You don't scroll much. You see all it takes. You just do. You don't do Command F. You just go to open file, Command P if you're in Visual Code, and go directly to the thing you want to change. There's this, we achieved this vertical coupling that I said it was underrated. We finally achieved it because now everything is revolves around use cases. There's only one reason to change one file, and there's not many reasons. Like this is another solid principle. You don't have n reasons to go to a certain file. You just have one. That's why you don't share stuff between use cases. There's low blast radius again because there's no sharing. Maybe there's some shared stuff like entities, but that's part of the business. But other than that, there's no sharing. It's good for feature flagging. This is just a nice side effect because now you can swap use cases by another use cases. Depending on the case, you might want to mount different use cases, and it's more plug and play. So because each is doing one thing. Code is self-documenting, so the dependencies are obvious. You just inject one in a certain class, one or two dependencies, and you can clearly see, oh, this guy depends on that. Great. You have everything it takes into one place, DTOs, etc. And we achieve this goal of streaming architecture as we saw before. When you browse the folder structure, you can see what your app revolves around. But I think to sum it up, this is what we achieved with this approach. This is a nice book that I think it complicates a little bit, but it mentions most of what I said. I recommend it, and just some articles that I wrote about this because I tried to, I was a bit fast to cover everything. It's impossible to cover everything in 30 minutes. And I think I'm over 30 minutes, so I'm done. Thank you. Okay, so do you still have time for questions, or are we, is it too late there?
So, okay. Questions, yeah, first, thank you. I had an idea before we could do the talk a bit longer, but this is would have been taking too much time. So any questions from the audience? Yeah, of course. Yes.
Hi, Luís. How do you deal with concerns when it comes to logging, caching, tracing, and so on? So how do you inject that into the domain itself?
I like to believe, and I think it usually applies that those examples you gave, those are technical concepts, and therefore they don't belong to the domain. At most, you might want to log, but even that, I think you probably want to have this error, for example, and log at the upper levels, at the outside layers. The same goes for tracing. The same goes for what was the other thing? Yeah, but regardless, those are technical concepts, and they can happen outside of the domain. I don't see okay, maybe there are exceptions, but in general, I don't see any reason to inject technical stuff into the domain, because even performance metrics, you can do it out from the outside of the domain, because you can route your call to the domain and do whatever you want. But again, there might be exceptions if they are, you inject them normally into the use case, like any other dependency. Like the same way you inject a repository, you may inject a monitoring tool or something like that.
Okay, so one more. I think there's one in the Q&A chat or of FAQ chat. I think. Oh, you got one. Yeah.
Hi, there are two questions in the Q&A.
Okay.
We'll just read them. I saw that there are many examples of projects that carry the DDD concept in public repository. My question is, do you have a reference for the project structure and Golang programming language that you see in accordance with the DDD concept that you presented? Or you can show the project structure according to what you are presenting.
I think I screenshot a little bit of a real project in Python where you saw the use cases, but I don't think there should be a strong rule regarding that, because when you start your project, probably you only need two folders, like domain and infrastructure, and even that you might skip, as long as the concepts are well defined in your head. But as you go along, you just adapt. You just need to follow that rule about separating business code from technological code, and I think that's enough. Like I don't think, maybe a good folder structure helps to promote that, to encourage that, but if the developers don't have this in mind, the folder structure is not going to help much. They have to have these ideas in mind first, and then the folder structure is just a consequence of that.
Yeah, I would like to add a few Go-specific things here quickly. Number one, the folder structure is in Go the package structure also, and this is the main package is the main way of encapsulation that we have in Go. We don't have classes or something like that. So the directory structure, folder structure, package structure is really the important thing, because it gives us encapsulation and we can separate things that way. And the Go team has always been a bit reluctant to say, do it this way or do it that way, because they always said it's depending on the use case and think about it yourself. But there have been some suggestions now lately about how to structure a module. You can find articles about that, even I think one from the Go team now. So there is some more official blessing around that, and that goes in line with what you have told. So it's that different from the structure that you have shown from Python. Right? They also say, make it obvious what your business logic is, what your use case, what you're doing, right? And not the technical stuff. This is secondary. Make it obvious what the application is really doing, and then everything else can follow from there.
Okay. Yeah, because this is like metrics, like I don't know, velocity. The problem with these metrics and the problem with this folder structure and the problem, I don't know, code coverage. All of this is that people end up trying to follow and pursue that rather than the values that are behind that. That's why I think it's a bit dangerous to try to sell that. So I think it's much better to sell the values that are behind this, and then you do whatever you want. Because it shouldn't be strict. It shouldn't be a done deal or written in stone. You evolve as you go and you refactor as you go. So I think you can have some inspiration, maybe. I can try to share that for inspiration, but should be only that. You shouldn't pursue that. You should execute your values, and the rest is a side effect of that.
Second question from the Q&A session in Zoom. What is the solution if one domain needs data which belong to another domain?
I kind of hinted that on the Venus project, those cities, the city metaphor. So that's why adapters exist, right? They adapt the languages to the between different apps. When I say app, just to be clear, I don't mean mobile app or web app. An app can be just something that is deployable anywhere. And again, the adapters on each one of the sides are doing that conversion between the domains. Within the domains, you have total separation of domains, right? But they cannot talk directly to each other. One, because it does make sense. Second, because they cannot, right? They simply can't. They need technology in between to do that. And that technology is doing that conversion between these different languages. But yeah, this is hard to tell. It's a generic question, so I don't have much else to say.
Was one more question? Yeah. I try to throw again. Careful.
Hi, Luís. Thanks. I totally agree with that. Separating infrastructure from business logic is a really good goal. I find myself many times where I have a lot of business logic implemented in SQL queries, but SQL queries are infrastructure by default, right? So how do you approach that part? How can you separate that?
What kind of business logic? Can you give an example, like triggers, database triggers and constraints?
Like queries, computing something, which is just way more. In many cases, I have to do it in SQL because it's just the way more efficient way to do it in SQL than loading everything and then put an array of 20,000 objects into a use case method.
But use cases don't tell you that you should load everything into memory, right? They
So would it be
They
fine to have the SQL code in a use case?
No, I didn't mean that. Probably that for sure should be hidden behind the repository function. And by the way, the repositories shouldn't necessarily just encode read, write, update, or whatever those generic functions are. This is just the starting point. They can do much more than that. Then you can have a specific, meaningful use case method that kind of almost self-documents what it means, right? Give me that, ordered by that, I don't know. But again, yeah, the you might call it logic, but I still call it data concern, right? It's the way you're going to access that. If it was a file system, it would be different. So in the end, the use cases want the data. They don't care how the data is achieved, right? Is gotten.
I see. Yeah. Thanks.
And I think I understood now the previous question, which was about how the domains talk to each other, because we had a similar issue before. And I think there are two strategies. Whether you have like for example, if an app, a mobile app needs some data from two domains, there are two valid strategies whether you have like something in between, which is usually called a backend for frontend that joins the domains into one and then feeds the app. Or the second strategy is like more API first, where the app knows a little bit more about the domains and then, I don't know, ask the transfer orders, and then I need these products as well. Let me get them from the proper service. It's a trade-off. There's no definite answer. It's a trade-off. I like the both strategies. It depends.
Okay. Thanks. More questions from the audience here? Good. Anything from online? Good. So, yeah, thanks a lot. So,
Thank you. It was a pleasure. Maybe next time I'll go there. Thank you for the opportunity.